So our today's topic is GOC, means re- inductive effect resonance, means reaction mechanism.
Yes.
So let us start. First is inductive effect. So inductive effect is when we have carbon-carbon chain, and at the end of the chain a group is attached, like chlorine, means any group which is either electron withdrawing or donating. So if it is electron withdrawing like chlorine, so chlorine withdraw electron from carbon.
Yes.
So this chlorine get negative charge and
Yes.
carbon attached to it get positive charge. So
Yes.
the first carbon will get positive charge, so it will withdraw electron from the second carbon.
Yes.
And therefore again second carbon get positive charge but less than the carbon atom which is directly attached to chlorine, and third will get positive charge less than that. And it means, what is inductive effect? It is permanent displacement of sigma electrons. It is permanent displacement of sigma electrons towards or away from the chain, from the carbon-carbon chain. Now, if it is away from the carbon chain, like in this case which is mentioned here, that is chlorine is attached to the carbon chain, then that is called minus I effect. And if there are groups like alkyl group, so alkyl group is electron releasing, and therefore it is called plus I effect. And chlorine, as it is electron withdrawing, it is called minus I effect. So inductive effect is of two types. They are of two types. First is plus I effect and second is minus I effect. So plus I effect means electron,
Donating group is attached.
yes, electron donating groups, if they are attached, then it has plus I effect. If electron withdrawing groups are attached, then they are showing minus I effect, like chlorine, bromine, iodine, fluorine, nitro. Nitro is more than, okay, and more the number of carbon atoms, more is the plus I effect. So order of plus I effect, methyl, so ethyl has greater plus I effect than methyl, and at the same time if two methyl groups are attached, that is called isopropyl.
Yes.
So it has more plus I effect than ethyl even. And if we have groups like it is tertiary butyl group,
Yes.
it has more than this, means more is the number of methyl groups, more is the plus I effect.
Understood. So what are some other examples of electron donating groups?
Like if we have oxygen with a negative sign,
Oh,
if any group which has negative charge like COO negative, so they are also electron withdrawing groups, sorry, electron releasing groups.
okay.
Any group if it has a negative charge, that means it becomes electron releasing. But if we write oxygen like OH, so it has minus I effect.
Yes.
Likewise, okay.
Understood.
Now application. So first application of inductive effect, let us discuss basic strength of amines. Out of ammonia and methylamine, which one is more basic?
Oh, so most basic is
So see, how do we see?
most basic would be methanamines.
Yes, it is methanamine, because you know, if we compare these two molecules, NH2 is common,
Yes.
both have lone pair.
Yes.
Now in first case NH2 is attached to hydrogen,
Yes.
in the other case NH2 group is attached to methyl, and you know methyl has plus I effect, so that's why it releases electron towards nitrogen. So electron density on nitrogen increases.
Yes. So it holds on to the hydrogen atom.
So as electron density on nitrogen increases, therefore its electron donating power is more. And more electron donating power means more basic nature.
Yes.
So that's why methylamine is more basic than ammonia. So this is the first application of inductive effect. Another example, acidic strength of different carboxylic acids.
Yes. We attach electron withdrawing group to alpha beta carbon.
See, any acid, let us say, instead of carboxylic acid, let us say HA is an acid. Now this acid will give H plus, because acid is the one which gives H plus ions.
Yes.
So it depends on two factors. First factor is strength of HA bond, and second, when HA bond breaks, after breaking we get this anion.
Yes.
So second factor is stability of anion formed. If more stable anion is formed, it is more basic, more acidic. So that means acidic strength is proportional to stability of anion formed. So tell me, anion becomes stable by, how do we increase the stability of the anion formed?
Stability of the ion form. Okay, by attaching any electronegative groups.
Yes, so stable means anion means negative charge.
Yes.
So it is unstable because of negative charge.
Yes.
So any group which decreases its negative charge stabilize the anion.
Understood.
So electron withdrawing group will decrease the electron density on the anion, means decrease the negative charge and therefore stabilize it. That means electron withdrawing groups increases its acidic strength. Electron withdrawing group in case of inductive effect means any group which has minus I effect. Second, if we attach electron releasing groups, means any group which has plus I effect, then acidic strength decreases, and it is also inversely proportional to strength of HA bond, because if bond is strong, then it is difficult to break, and therefore it will not give H plus sign easily. So now let us suppose we have these two molecules, methanoic acid, also called formic acid, and acetic acid, also known as ethanoic acid.
Yes.
So out of these two, what is the order of acidic strength? Which one is more acidic?
Formic acid.
Now methyl group has plus I effect,
Yes.
therefore it decreases its acidic strength
Yes.
because it decreases the stability of the carboxylate ion formed. So if we have group with more plus I effect like ethyl, isopropyl and tertiary butyl, so here we see more are the number of groups, more is the inductive effect, either plus I or a minus I. So see, here plus I effect increases
Yes.
because groups are increasing. Same is the case with chloro groups. If we have monochloroacetic acid, we have dichloroacetic acid and trichloroacetic acid. So tell me, what is the order of acidic strength?
So trichloroacetic acid is the strongest.
Yes, here in first case there is only one chloro group. In the second case there are two chloro groups. In the third case there are three chloro groups. So minus I effect increases, and so electron withdrawing effect increases.
Yes.
So acidic strength increases. So this is more are the number of groups, more is the inductive effect, either plus group I groups or minus I groups. Now other one is like we have one chlorobutanoic acid, two chlorobutanoic acid, three chlorobutanoic acid, and 4 chlorobutanoic acid. So what is the order of acidic strength?
2 chlorobutanoic acid is the strongest.
So 2 chloro is more acidic than 3 chloro than 4 chloro. So one more inference is there that
Yes.
as distance of the group from the polar group increases, distance of the attached group from the polar group increases, its effect decreases, means inductive effect decreases with the distance. Inductive effect decreases with the distance from the polar group. So that's why inductive effect has negligible effect after third carbon. There is maximum effect on the first carbon, then inductive effect decreases, and after third carbon it is almost nil.
Okay.
Then let us say fluoroacetic acid, chloroacetic acid, bromo, ido. So you know fluoro has more minus I effect than chloro, than bromo, than ido. So fluoroacetic acid is more acidic than chloroacetic acid, then bromoacetic acid, and then idoacetic acid.
Yes.
Okay. Okay. Next is stability of carbocation. So see, the carbon containing positive charge is called carbocation.
Yes.
Methyl carbocation is a special case. Ethyl treated as primary, but ethyl carbocation is primary carbocation because positively charged carbon, if it is attached to only one carbon or no carbon, that is called primary carbocation. Then secondary carbocation, isopropyl carbocation is secondary carbocation, and this one is tertiary carbocation. So tell me which one is most stable? because say positive charge, it is unstable because of the electron deficiency. So any group which decreases its electron deficiency, like methyl group is electron releasing, so it will decrease its positive charge, decrease its electron deficiency. So due to this, these electron releasing groups decreases the positive charge, and therefore stability of carbocation is in the same order. Means as plus I effect increases, magnitude of positive charge decreases, and therefore increases stability of a carbocation. Now stability of carbon ion. This is tertiary carbocation. Now stability of carbon ion. So in carbon ion, instead of positive charge, there is negative charge.
Yes.
So again they are unstable because of, means any charged particle, any charged group, any charged ion that is unstable because of its charge. So any group which decreases its charge, that will stabilize it, and any group that will increase its charge, that will destabilize it. So if you compare them, see these methyl groups, what they do? They will increase the negative charge or decrease the negative charge. So methyl groups will increase the negative charge and therefore destabilize it. So if we compare, methyl carbocation is most stable, then ethyl, then isopropyl, and last is tertiary butyl. So this is methyl, this one is ethyl, isopropyl, and tertiary butyl. Now next is stability of free radicals.
Yes.
Now free radical means, what do you mean by free radical? It is neutral molecule having one unpaired electron.
Yes.
So you know carbon has 4 valence electrons. Out of 4, 3 are shared with the other groups or atoms, and 1 electron left unshared, and that's why it is called free radical. Methyl free radical, ethyl free radical, isopropyl free radical, and tertiary butyl free radical. So first tell me, free radicals are electron rich or electron deficient?
Neither.
It is electron
Neither separate.
they are electron deficient because you know any atom or group should have octet of electron. So see, in this case carbon has 7 electrons, so it is deficient of 1 electron, so it behaves just like carbocation. So any group which will increase electron density on the carbon, free radical carbon, that will increase its stability. So in this way tertiary butyl free radical is most stable, isopropyl, ethyl and methyl. So this is the order of stability of free radicals. So these are few applications of inductive effect. Now come to next, that is called resonance effect. Just like say inductive effect is permanent effect, but permanent effect of displacement of sigma electrons. Resonance effect is also permanent effect. Permanent effect of delocalization of pi electrons. In inductive effect there is delocalization of sigma electrons, so that operate mainly in saturated compounds. Means inductive effect is mainly for saturated compounds, and when compound is unsaturated, in most of the cases resonance effect operate, and resonance effect is dominating over inductive effect. Means if both the effects are operating at the same time, we will do some questions related to that, then resonance is dominating over inductive effect. So first of all, resonance effect is permanent effect, and it is permanent effect of delocalization of pi electrons. And when resonance takes place, either when two double bonds are separated by a single bond, when double bond is in resonance or is in, that is also called conjugation, is in conjugation with lone pair, or double bond is in conjugation with positive charge, or double bond is in conjugation with free radical. So in these cases resonance effect takes place. So let us take a case. Yes, it is also of two types. So types, again plus R effect and minus R effect. Again on the same line, plus R means electron releasing groups. Electron releasing groups will show plus R, and electron withdrawing groups will show minus R. Now how do we identify that this group will show plus R and other one will show minus R? So like let us take common example of benzene. Now on the benzene, if atom which is directly attached to the benzene that has at least one lone pair, two lone pairs are not required. One lone pair, only one lone pair can undergo resonance. It is only in conjugation, other will remains as such. It doesn't mean if two lone pairs are there then it has more plus resonance effect than the other one. Like if we have OH group or NH2 group. NH2 has only one lone pair, OH has two lone pair. But in conjugation or in resonance only one lone pair is required. So condition is those groups this is very, very important. Plus R effect is shown by those groups which has a lone pair on the atom directly attached to the unsaturated system. What it means, like see in OH there is a lone pair, in conjugation with the unsaturated system again lone pair, but if it is like this, tell me, this OH will show plus R effect?
Yes.
This will also show plus R effect?
Yes.
And what about this NH2?
It won't, sir.
Yes, it does not show. So which effect will it will show? It will
show reductive effect.
Yes, minus I effect, because nitrogen is more electronegative than carbon, and this nitrogen is attached to saturated system.
Yes.
So whenever there is a saturated system, there is inductive effect.
Understood.
At the same time, this OH group also has minus I effect, because obviously oxygen is more electronegative than carbon, so it will show minus I effect. Again, nitrogen is more electronegative than carbon, it has also minus I effect. Now see, first one has plus R effect and minus I effect, both are opposing each other, because plus R means electron releasing effect and minus I means electron withdrawing effect. So which effect we will consider?
We will consider minus I effects. No, plus R effects, sir.
Yes, resonance is dominating over inductive effect. That I told you, that resonance effect is dominating over inductive effect, except in halogens. Halogens is a special case that has an exception that I let you know afterwards. First we will discuss, whenever resonance and inductive effect is there, then resonance is always dominating over inductive effect. So both the groups are considered as electron releasing groups. Now we will draw resonating structures. This lone pair becomes pi bond and pi bond becomes lone pair. So see, it is like this. Now because OH is electron releasing group, it will increase electron density on the benzene ring. So whenever electron density on the benzene ring increases, which group will attack on it, electrophile or nucleophile? And obviously, you know, group which will attack on the ring is either electrophile or
Nuclear.
so I wanted to know that if benzene is there,
Yes.
so benzene, is it electron rich or electron deficient?
Electron. Right now, sir, in this resonance structure.
No. Let us say we have benzene only.
Yes.
So benzene is electron rich or electron deficient?
Electron deficient, sir.
It is electron rich because each carbon is attached, it is sp2 hybridized,
Yes.
and at the same time it has one unhybridized orbital, p orbital, on each carbon, and that will form pi bonds.
Yes.
Either in the way I have shown or in the other way around.
Yes.
So in actual, all the p orbitals, they overlap with each other.
Yes.
So there is pi electron clouds above and below the plane.
Yes.
So because of these electron clouds above and below the plane, okay, so this carbon and hydrogen skeleton is means encompassed by those pi electron clouds,
Okay.
and therefore that pi electron cloud make it electron rich.
Alright. So I said electron deficient because of the saturation.
Yes, I know your why you said this, but got my point. Why it is electron rich?
Understood.
Now, if it is electron rich, which species will attack on it? Electrophile or nucleophile? So electrophile. So benzene undergoes electrophilic reactions, right?
Yes.
And in spite of high degree of unsaturation, they will show electrophilic substitution reaction rather than addition reaction.
Yes.
Otherwise, unsaturated compound will show addition reactions. But here, it undergoes electrophilic substitution reaction. Why? Why electrophilic substitution and not electrophilic addition?
Because it has a revolving negative charge.
Because there is a delocalization of pi electrons, it is aromatic, and the benzene does not want to lose its aromatic character, and therefore in spite of high degree of unsaturation, they will undergo electrophilic substitution reaction rather than addition reaction. Okay, now when we attach OH, it is simple benzene.
Yes.
Now we attach OH. So OH is showing plus R effect,
Plus R. Yes.
means it is electron releasing group.
Yes.
So it will increase the electron density on the ring.
Yes.
So, what is the name of this compound? Phenol.
Yes.
So phenol, is it more reactive than benzene or less reactive than benzene?
It is more reactive.
So phenol is more reactive than benzene towards electrophilic substitution reaction
Yes.
because of plus R effect. And when this plus R effect takes place, electron density is increasing on the ring, particularly at which position?
Ortho and para position.
Yes, ortho and para position. So keep in mind, resonance always takes place at ortho and para position only.
Yes.
So it will increase electron density at ortho and para position. So any group which is electron releasing, means these groups, electron releasing groups on benzene ring are activating
Yes.
because they increase the reactivity of the benzene.
Yes.
So they are activating and ortho para directing, because electrophile will attack on the benzene ring more than in benzene, but particularly at ortho and para position, because these groups will increase the electron density on the benzene ring, particularly at ortho and para position. So they are or
Exception for aniline that it gives significant amount of meta products.
there is no exception. There are few examples and the reason is different. Like if we do the nitration of aniline,
Yes.
then there is a significant amount of meta product, but reason is different. That I let you know afterwards. Okay. Now, so any group which has lone pair on the atom directly attached to the benzene ring will show plus R effect. Now, case of chlorine. Means any halogen. So in this case, again there is a lone pair.
Yes.
So as it has lone pair, again same, we can draw the resonating structures.
Yes.
So it is again ortho-para directing.
Yes.
So chlorine has plus R effect and minus I effect, same as that of OH and NH2.
Yes.
But in this case, in halogen especially, inductive effect decides the reactivity. So that means chlorobenzene is less reactive than benzene, but R effect decides the orientation. Means they are ortho-para directing, but at the same time they are deactivating. So this is the, yes, because of high electronegativity we can say they are deactivating, and because of resonance they are ortho-para directing. That is different from the other groups. Now minus R effect. So any group which has pi bond, attached to the atom, directly attached to the ring, that will show minus R effect. So in first case, when we are talking about plus R effect, the atom directly attached to the ring should have lone pair. And in this case, when we talk about minus R effect, then any atom which is directly attached to the ring should have pi bond. And if that pi bond is attached to more electronegative atom, that will increase the minus R effect. देख लेना. So CO pi bond. So obviously oxygen is more electronegative than carbon.
Yes.
So pi electron shift towards oxygen, and therefore oxygen gets negative charge, and at the same time carbon pi bond shift like this, and at ortho position we will get a positive charge now.
Alright.
And again that positive charge shift to para position. So electron releasing effect or electron withdrawing effect, both will takes place at a ortho and para position. Means the resonance takes place at ortho and para position only. This is the case. So any group which has minus R effect, decreases electron density on the benzene ring, so if electron density decreases, attack of electrophile on the benzene ring decreases, and therefore it decreases reactivity. It decreases reactivity and is deactivating group. That means if a group having minus R effect is attached to the ring, that will decrease its reactivity towards electrophilic substitution reaction. And it decreases electron density particularly from ortho and para position, and therefore it is meta directing. So they are meta directing groups. So now I will take up the case that you have mentioned. Like we have aniline. Aniline, if we do its nitration, then obviously we are expecting that NH2 group, as it is ortho para directing because it has plus R effect, so it will give ortho nitro aniline and para nitro aniline.
Yes.
These are the expected products, but surprisingly meta product is also formed, and that is not in lesser quantity, it is around 47%.
Yes.
Para product is 51% and ortho is only 2%. So why this huge amount of meta product is formed? Because you know aniline is weak base. This because of the presence of lone pair, it is a base. Now HNO3 H2SO4 both are strong acid. So as they are strong acid, there is an acid base reaction. So when this acid base reaction takes place, we will get anilinium ion. So like I said, O negative, CO negative, they are electron releasing groups.
Yes.
So NH3 positive is electron withdrawing group. This one is electron releasing group. So that's why this is meta directing. So due to the formation of anilinium ion, we get meta product in significant amount. Got it? Okay. So now if we have methylamine and aniline, if we talk about application, so tell me which one is more basic?
Methyl.
So obviously methylamine is more basic because this methyl group will increase the electron density on nitrogen, but here aniline, in aniline, benzene ring will take up this lone pair and therefore electron density on the nitrogen will decrease. As NH2 has a plus R effect, so obviously benzene ring has minus R effect, and therefore it withdraw electrons from nitrogen, and therefore electron density on the nitrogen decreases. Therefore methylamine is more basic than aniline. At the same time, second application is what is responsible for the acidic nature of carboxylic group? Why carboxylic group is acidic?
Electronegative oxygen atoms.
Because when we get carboxylate ion,
Yes, and it has internal resistance.
see, both can have resonance. See, in first case, you know, this lone pair is in conjugation with pi bond. So see, there is a separation of a positive and negative charge. In carboxylic group, there is separation of charges. But in carboxylate ion, there is delocalization of negative charge. So as there is a delocalization of negative charge, carboxylate ion is more stable than carboxylic acid. Got it? Carboxylate ion, because it involves delocalization of negative charge, it is more resonance stabilized than carboxylic acid, which involves separation of opposite charges, and therefore this accounts for acidic nature of carboxylic acid. Got it?
Understood.
Now if we have like methyl benzene, So to do chlorination, FeCl3 or AlCl3, okay, let us say we have OCH3. What is the nature of this group? It has plus R or minus R effect? Plus R. Say, just see lone pair on the atom directly attached to the ring. That is the funda behind it. Okay, so it has plus R effect. So it is orthopara directing.
Yes.
So if we do the nitration, in nitration, see what is the role of these two. One is HNO3, other is H2SO4. Both are strong acids, but when both are present together, so H2SO4 behave as acid and HNO3 behave as a base. In this is called nitrating mixture. So in nitrating mixture, if question is like what is the nature of HNO3 in nitrating mixture,
Yes.
if it is simply what is the nature of nitric acid, everyone knows it is acidic. But if question is like this, what is the nature of nitric acid in nitrating mixture? So it is basic. It accepts H plus ion from H2SO4. This is the product form, and then H2O is removed and we get NO2 positive. So this is the electrophile which will attack on the anisole. This is called methoxybenzene, is called anisole.
Yes.
So OCH3 group, with respect to OCH3 group, methoxy group, where NO2 positive will attack?
Ortho and para position.
Yes, at ortho and para position, because that will be directed by the plus R effect of OCH3. So any group which has a plus R effect, that will direct the electrophile at ortho and para position. So ortho nitroanisole and para nitroanisole we will get, out of which para being symmetrical is major product and sterically less hindered, and here it is minor product. Same if we have benzaldehyde, let us say. So in benzaldehyde, if we do the nitration, which product will we get?
Meta products.
Yes, so in this case, because this group has minus R effect, it is meta directing, so we get meta nitro benzaldehyde. So this is these are the applications of plus R and minus R effect. So we will continue these effects tomorrow.
Okay.
Next is hyperconjugation. Just do the questions related to resonance and inductive effect, and send me if you have any doubt.
Alright.
Okay. And then hyperconjugation, electromagnetic effect, and some mechanisms like Markovnikov rule, anti-Markovnikov rule, Sergev rule,
Okay.
even Hoffman rule. We will elimination E1, E2, nucleophilic substitution SN1, SN2, that we will do in the next coming sessions. Okay.
Alright.
Okay then.
Thank you so much.
Welcome. So we will continue the class at 5 o'clock beta. Tomorrow at 5 o'clock be in the class. I will complete this GOC, means whole GOC I will complete within 2 or 3 days, up to maybe up to Sunday. I will try to complete it. So be with me. I will definitely help you out in clarifying the doubts of organic chemistry. You can send me doubts on I have Chemistry Gyan Academy app. You can download from Google, and from where you can send me doubts if you have. I will take up those doubts in the coming sessions. So goodbye. Thank you so much to be with me. I'm happy to help you. So happy learning. God bless you all, and do subscribe my channel and share with others so that they will be benefited. So see you tomorrow at 5 o'clock. Have a great day. Great.